All right, I'm putting this video together for Arch 21-22 Foundations Architectural Design Spring Semester. This exercise is looking at the translation of our designs into a physical model format. And to do this, I've put together an existing model. I think for everyone's project, we'll be starting from the same canvas, which is this sort of lattice framework of dowels and floor plates. This model will be prepared at 1/8 inch scale, and what that means is our 1/4 inch dowels are at about 2 feet in real world scale. For the floor plate, I'm using an 1/8 inch material, which equals about a foot, which is pretty generous. You could go thinner for the floors. Let me turn off some of these other pieces. All right, and so you'll see I'm starting to make some explorations. We'll get into that in a moment. I do want to show some techniques for translating each of your unique designs into the physical form. But let's start looking at this. And so I'm here in a Rhino file. If I zoom out, you'll see one, I have the existing building. My scale is at inches. I have the existing building provided to the class right here at 1/8 inch scale. But I also have right here, and I have a clipping plane right now. I can pull this off, and you'll see I have the actual model as well. I've hidden it so that when I'm working here and I'm rotating, my camera orbit is not like working on this, city block scale when I'm trying to work on a, tabletop sized model. So I recommend if you guys are doing the same thing to isolate your model. You can even export it into a new model. So looking at what we are starting with, really the only elements that need to be translated into the physical model to start before we look at design are the floor plates, the structural system, and for this I'm oversizing my structure comparatively. So the floor framing here could be a smaller size dowel. You are welcome to use 16th inch for that. I'm going to be using 1/8 inch, and I'll get into some of those measurements later. So floor plates, including ground floor, second floor, and the roof. Perimeter structure, which would be 1/4 inch dowel. Interior structure, which would also be 1/4 inch dowel. And then the site. I'll be getting into the site later in this video, and these dimensions will be potentially class specific, so that'll be accompanied in the presentation with this project. But we will be doing a portion of the site at 1/8 inch scale. To get you guys, let's leave that clipping plane. To get you guys from here to here, I'm going to use a scaling trick that has worked for me. It's really foolproof. So I'm going to go into the top view here. And when you're doing this, if you're working in one model, I do recommend making a copy. And so you can see over here on the layers panel, I have put my existing model, my full size model, into a sort of like sublayer. It's all sublayers under one major layer. And that lets me turn it off really easily. Lets me lock it really easily. And it also lets me right click it and select sublayer objects. Now, when I do that, you're going to see I grab some of this stuff down here, which I don't really want right now. And so I can control click and deselect all of that. All right, I'm going to move this over for a moment. And so the scale trick, I've probably shown this to you guys in class, is to draw 2 lines. Let me make this a bit more visible for you. And so first thing we're going to do is draw a line that represents our starting scale, which is 1 foot or 12 inches. My model, my unit is in inches. I do recommend, if you look down here, you'll see that. I recommend working in inches when you get to this scale, the model scale. Real world scale, it's really personal preference, but once we move down, it's going to be really inconvenient to try to always type inches and not be working in feet. And when you're converting that, you can type units, and it'll be right here. You can keep the model display at feet and inches, but change the actual model units to inches. And you'll see if I go here to feet, I get this option. So when you're going from feet to inches, you want to make sure you're using this. It'll preserve the scale of everything without, distorting the size. That first checkbox is going to convert your units exactly. So 1 inch becomes 1 foot. We don't want that here. So here's what we're going to do. We have our 1 foot line that represents real world scale. We'll do our 1/8 inch line, which is 0.125, right below it. And so when I'm using this right now, this would be your design model right now. All of you guys have made pretty advanced 3D models for your perspective studies and your plans. So take that, make a copy, and then you're going to select the entire thing, make sure nothing's locked or hidden, and then come in here, type scale. You'll see it says base point. That'll be the beginning of our 12-inch line. Scale factor or first reference point, we're going to pick at the end of our 12-inch line, which is the 1 foot in an 1/8 inch equals a foot. And then it's going to ask for our second reference point, and that'll be the 1/8 inch line. I press tab here so that it locks the direction. You'll see if I don't press tab, it'll take this length between these 2 points. We don't want that. We want to keep that length along the same axis, so it's exactly 1/8 line. You can see that down here. When I hold it, 1/8 inch. Perfect. Okay, so that's the first step before we get into any of this stuff right here. And so let me hide all of this because I don't need it anymore. When we get down to model scale, this is what we have. And so I think the first thing to kind of confront is that this is sort of the import, right? This is what we're starting with. This is your design, your project. The physical models we're going to make of these are representations of the project. They are not the project itself. And so I think the best approach for the cleanest models, especially trying to capitalize on the precision of digital fabrication, is to essentially rebuild these, to rebuild them with the materials that we have right here. And so if you look at my layers panel, you'll see that I've sort of set this up. I have my existing model and I have my 1/8 inch scale model, and I have 4 components of that at the moment. These are sort of different materials in there. And some of these are just to demonstrate techniques. We'll get to that, so just ignore it. But right now I have the 1/4 inch structure, which are the dowels. I have 3 16th inch cardboard, which I'm going to be using for the basement floor and the eventual model base. And then we have 1/8 inch mat board, which will be sort of like a 1 foot assembly, 1 foot in model scale. So I'm using it for the floor. You could use that for walls as well. You could even go to 16th inch if you want to have something that represents, interior walls or like a thin cladding. Also Bristol. So Bristol can be a sort of thin material assembly as well. It's really great for folding. There's, of course, multiple types of materials in that paper category. You could use craft paper. You could use some sort of like colorful paper to represent, different types of metals, um, or even green paper to represent like green roofs and site work. There's also acrylic, which I'm not going to be using in this model. I would say acrylic should be pretty selective. Some of you guys have, sort of growing spaces, greenhouses. I think acrylic can make sense there. Even if you go up to the print lab and take Mylar and cut that by hand, you can use that as a sort of frosted glass. I would say, if looking, say this is my design project, where I have these windows, I'm not going to be filling every single pane with acrylic, and I don't recommend that you guys do that either. Use it sparingly. There's also materials like corrugated plastic, which could represent polycarbonate. During the presentation to the class, I'll share some more material techniques and even here the use of laser cutting. And so you'll see what I've done here is essentially rebuild this. And so to do that, I locked the model. These guys, I unlocked them because I was messing with them. So I locked those too. And then I went through, I have the ghosted view here. I have the shaded view. I also have wireframe, which is kind of crazy when it's locked like that. So I went through and rebuilt it. And so we'll kind of go through the order at which I did that. I started with 1/4 inch scale dowels to get these column locations. I prioritized, you'll see that they don't match exactly. So I prioritize the overall footprint of the building. I prioritize the center line of these intermediate columns. And then you see I use the outside edge here. For the interior columns. Now we're not going to get into detailing, but I was kind of breaking some rules here because I'm using one size dowel for everything. If you guys are being really accurate and you want really clean models, you can make these interior beams even smaller. But you'll see that my outside beams sort of hit flush at the top of floor. My interior beams hit the bottom of floor. So I'm not going to get into the nuance of that at the moment. This is not the studio for it, but just to know that there's some decisions to be made there. The other thing I'm going to change right now actually with the group is I'm going to pull these columns down because I don't really think they should be going to the top of the parapet like that. They should be going to the top of the roof. And so this is what we're going to be working with. And it's good to have both of these on their own layer groups so we can turn them off and toggle. And so this is where I started. Um, Laying out all of the beams, columns, perimeter structure. You'll see I even took some of them out here where we have the ramp. And then the next step for me was to do, I guess we'll say the bottom floor of it, which will be the basement, which I'm going to use 3/16 inch cardboard, specifically because it's going to integrate into my model base. And then I used the 1/8 inch mat board for the floors. And one nice thing is because we are going to try to capitalize on digital fabrication using laser cutting, I'm cutting the beams through these. And so there will be a bit of logistics in how you put this together, because if I glue all the dowels together, there's no way for me to sort of slot the floor plate on. So think about sequencing here. I can also laser cut these on this one. And then the roof, I have some openings here that we'll be looking at shortly. But for the roof, we don't really need to cut columns into it unless we're adding a third story. And so if you have a third story or some sort of addition, that's a great opportunity to add column holes into the roof. And so in that conversation, you might be extending some of these columns up for even taller stories. That's going to be on a project by project basis, but I do suggest as you're building this physical model, use it to confront some of the tectonics of your projects, whether you're doing a cantilever or you're adding a story or you're taking big holes like this out of the project and you're going to carry that, say I'd carry this and take out the structure like this. Sorry, it's a lot of things to click on in here. There we go. So, maybe I subtract structure here. It's a great opportunity to think about how I actually come in here um, with my own structure and potentially, reinforce this opening, right? Something like that. And so I guess a good rule of thumb as we're doing physical models is if it doesn't stand in your physical model, it's probably not going to stand in the real world. So it's a good conversation to have. We can also look at the use of materials as a cantilever. And so some materials, this is the ground floor, bad example, but if we look on the upper floor, can we sort of float things over the edge, which would be a good case to, maybe justify all of your beams downwards like this so that you can float your floor slab, let it hang over. I think in that conversation, this is a representation of your building. This is not the building itself. And so we can take some artistic liberties in its assembly. This is a design conversation. You're not going to take what you made in Rhino one-to-one and model it. And I think to that same conversation, looking at the scaled model, certain things like mullions, right? Let's look at that. It's 0 inches if I measure it. So let me actually increase the tolerance there to a 64th of an inch, which is nearly indiscernible to the eye. This is still 1/64th of an inch. And so I'm using this to say that certain elements are going to be too small at 1/8 inch scale to really render. And so you have to get creative. This is 3/128th of an inch. That is infinitesimally small. I would say do not try to laser cut these out because they're going to collapse. We can look at techniques for people that have glazing and they want to show the support. We can look at techniques for that. I'm going to suggest that you don't try to translate them one-to-one. Rather, look for a physical process that'll let you capture that intent. All right. And so this is the starting point for most of us. And then as you go through, I'm using this very boring existing model. I have not really done a design project like everyone in the class has. So to bridge the conversation, I have come in and I've created what isn't really a design project, but something that will let me look at techniques for each of you to employ in your own models. And so I just made up some materials here, creating this orange thing like a folded metal. I have some sort of glass infill on that. Some areas are open, some areas are not. Let me turn off the existing model. And then I have this Bristol, which I'm using in a couple different ways. All right. And so I have these because you guys are really pushing the boundaries of what is possible in a physical format, and I want you to continue that conversation with these models. And so there's really difficult forms like this thing, or even sort of compound angularity on a roof and on a facade, things that might fold and tuck, right? Openings within these, you might have screening systems mounted to different glass facades, or screening systems that wrap interior curves. And then you might have, these sort of sculptural compound curves that are sloping and wrapping. And so I'm going to go through techniques for each of these and how to begin translating them into physical forms. The whole time we're going to keep this sort of physicality in mind of what these materials are. And so you'll see if I zoom out, I actually have sort of delayed these things out. Down here I have what I measured as a 24-inch dowel. I found this on Blick's website. You can get packs of, I think, 25 2-foot long dowels that are 1/4 inch by 1/4 inch for about $20. I think with what I have here, it's going to take about 14 of the dowels in that pack. You'll see I'm not really maximizing some of them. So you guys can get really efficient. You can probably maximize the efficiency more than I am here. Also, if you're removing structure, you would have less dowels. If you're adding structure, you would have more dowels. If you're going to use a 16th inch dowel or something smaller for the interior sort of floor framing, that's really small and doesn't need to be quite as massive, you could potentially save some material costs. Right above it, you'll see I have my laser cut sheets. And so this is going to be transformative for how we can render materials and even expedite the assembly process. It takes a bit of practice, so it's a learning experience for all of us. You'll see here I have my 1/8 inch mat board, and the cut sheet I have it arranged to is 18 by 32, which is the size of the laser cutter beds in the Arch Digital Fabrication Lab. So I have one for mat board, I have one for cardboard. You'll see that these are set onto layers. The cut layer, as the laser cutter will see it, has an RGB value where red is 255, everything else is 0. And likewise, the score layer has a RGB value where blue is 255 and red and green are 0. And so you can actually feed these directly into the laser cutter. You would print, and the lab tech can help you with this. You would print and you could set scale. Now I don't have my page set up to the print bed dimension, but you'd essentially do this exact same thing, and you would cut from there. You'll input the material thickness, and that'll change the cutting speed and the power of the laser. You can also use scoring, and I'll get into this in a moment, to render materials. And so this is using a hatch. Now, the hatches are, not all of the hatches that I have right now are default to Rhino, so I can try to get those too. So first, let's start with some translation. The difficulty in using laser cutting is that everything needs to become planar. And unless you're going to start using 3D printing, you have to sort of reconcile that these really complex forms we've created need to become planar. So I'm going to delete these. Actually, I'll use these for a second. So let's look at this shape, right? First thing we're going to do, if you have a sort of poly surface that's closed, is just explode it. I use the middle mouse button to open this little toolbox, and I'm just going to click explode. And so now I can take it apart, and you'll see that I go from a poly surface to 2 flat planes and 1 non-flat plane. So there's a few tricks we can use for this thing. The most immediate one is unroll surf. And it says if you want to unroll it anyways. So doubly curved. Okay, so this is going to create problems, but that's okay. Let's see what we can do. And so the alternative here is to potentially simplify or use this as a starting point And then as we go into the physical model, to maybe abstract or modify the exact representation. You know, not everything needs to be laser cut out, but I'm gonna try. We're gonna try this. So the first thing I'm gonna do is I'm just gonna cut it in half, like this. And so I'm trying to find the midpoint, but it's kind of tricky because of this insane form I made. I'm gonna snap to the middle of that bottom hole right there. I think along this axis is the cleanest. All right. And so I'm going to use the split command, and now I have, um, let's try that again. That's very strange. It's given me 3 pieces, I think because there's a seam here. There's also a chance that if you go into your document settings, there are modeling aids, and I typically disable apparent intersections. So if you get really weird trims or splits or even Boolean differences, come into the settings and disable this. Likewise with trim, if I were to use trim right now on this, you'll see right here is also apparent intersections. I would disable that just so you have a more predictable command. So we can take these pieces, we can unroll these. Okay, it looks like a new command, Rhino, is always advancing. Smash would be better for this. Select curves to unroll. And so we're going to think about the axis of which we want to wrap this unroll. So I'm going to pull these apart. All right. So this will orient itself to our world origin, and so we'll get this right here. And you'll see that it's actually on my layer. And so I'm going to put this on the Bristol layer. We can keep track of, what material we're working with. And so it's hard for me to use my eyeballs right now and tell you that this is a one-to-one representation of this, but if I'm trying to reassemble this physically, it would be an excellent starting point. And again, with some of these folding techniques, if it's not one-to-one, if it's not perfect, that's okay. The physical model is a representation. So we'll do the same thing with these. Here's this. And if we feel really creative, we could try to orient some of these shared edges. It looks like, though, that compound curve is behaving really wild, so I'm gonna leave it be. All right. And then just for the sake of study, let's see what happens if we have this fully joined. I think that as a fully joined poly surface or compound curve, it's gonna behave. Okay, it actually did the exact same thing. Now I wonder if it did that because the seams exist in it. So let's copy those to our clipboard and just undo all of this. Back to here. Here we go. So that actually feels pretty predictable. Just to do some napkin math, checking the two areas, they are within like a tenth, a hundredth of a decimal place, a thousandth of a decimal place. So I think both of these techniques will work pretty closely. And so that's for this. I mean, I don't think anyone really has this in their project, but I do want to look at this right here. And so this is looking at sort of a volume, and I hope that each of you guys can recognize the techniques that are geared towards each of you. If not, the DC instructor and we can help you guys arrive at solutions to translate your projects. So we'll start with this. This is likely going to be similar, where we can pull off the top and we can pull off the bottom. And then, I have another planar face. We can pull that off. And so what we're left with are these. And so let's see if Unroll participates on this one. Select the edges to unroll. think it already knows what we're doing. Right. And so this is a better candidate for the unroll command. And so I think because we've exploded it, we get individual ones. Let's see if we join it. Actually, it is still joined. Did I join it? Interesting. So it breaks it into fragments. And then I think, I'm curious if we can piece these back together. Nice. All right. And so for this piece, we have one more part. Um, this we could do like a smash command on. I feel pretty confident that I can rotate this 3D and get that like perfectly planar. We can check it in both of these projections. If we see any sort of deviation, we'll know that's not flat, but it is. And so I'm using really just a simple rotate 3D. I don't know how I know that this is going to work exactly, but it does. And so there's a translation for a sort of shape like this. And so we take the tops and bottoms apart. We can even take this edge, this sort of edge face. We could actually build that into this sort of compound fabric. Although this might not be on the right side. Let's look at this. There's an inside curve and there's an outside curve. So this would probably go. I think this actually goes in between these two. Right, nice. And so we probably could have unrolled those together and gotten that piece sort of incorporated, but there it is all together. And so the next step is we take this, we'll come into the top view, take these, and we can explode them. Or, actually, I don't even know if that works. No. The command I meant to say is extract wireframe. And so you'll see, you guys might be accustomed to seeing, I'll look at that a little inaccuracy. You guys may be accustomed to seeing ISO curves. And so in my Rhino settings, I actually have those disabled by default in just about every view. So if you look here, all the ISO curves are typically turned off. X-ray, X-ray, I don't know who uses that. But wireframe shaded, rendered, ghosted. I have my ISO curves disabled. If you don't want to turn them off in the view, but you want to turn them off for an element, you can select the element and you'll see right here ISO curve density. You can disable show surface ISO curve. I say this because with the extract wireframe command, if those are visible, it will generate ISO curves. So I think if I even say turn them on, you'll see I generate ISO curves. Now these can be useful in certain contexts, but for what I'm doing, I just want the outlines. And so I'm going to delete these. And so with my wireframe, we can prepare this for laser cutting. So I'm going to make another cut sheet for my Bristol. All right. And thinking about how this will come together, we want to cut the outside. And so select all the outer curves, and we'll set that to the cut layer. Now, there is a bit of trickiness here when it comes to these. I think the first thing I would say is if you are bending the paper, you do not need these vertical lines. You can delete them, with the exception of these guys on the sort of flat face that we would fold. So that's one thing. We can use these top and bottom pieces, which I'm going to join so I don't lose any curves, make sure that they stay closed. You can use top and bottoms to understand how these faces wrap, right? And so you can take this folded piece of paper and you can sort of wrap it around this as a scaffold. The other thing is that, say we wanted to keep the vertical lines, and we'll get into this on the angular portion over here. If we wanted to fold these, let me bring them back, we need to think about the orientation of the folds. Because if we put these all on score layer, like this, the paper is going to want to fold away from this cut, like that, right? And so if we have something like this that's two-sided, we want to make sure those score lines are on, I guess I'll say, the outside face of these curves. And so that goes for this outer curve, and that goes for the inner curve. So if we did it this way, right, where it's one piece, you'd get those lines on the inside of this curve, and they would not be following the direction of the bend. So I think the correct solution is if I wanted to cut this and have it all sort of fold together, if we wanted to keep these lines, I would actually want to mirror this, right? And now I have the sort of inverted face here. And when I laser cut it, these lines will actually be inside. They'll be on the outside face of this. So I think for this kind of operation where we're folding paper, we don't need them at all. Besides here, where we know we have a flat face. And you'll see I actually have doubles. I'm going to just delete those out. You can also do a make 2D at the very end once you've set up everything to flatten everything. That's good practice as well. And then I'm just going to take my outline and I'm going to join it. I recommend joining your curves for cut outlines because the lasers need help giving us clean products. And so if you have a bunch of seams, see all these joints, individual lines, there's a chance that the laser will cut it like that. Or at the very least, it might even stop at those points. And then you'll get little hot spots in your materials where the laser either slowed down at a vertex or stopped and moved to a different line. So hold its hand, take control, and join these curves so you get a nice clean outline. I also think this is a good time to say that make sure you are laser cutting curves and not surfaces or poly surfaces because it will behave differently and it will not give you a good product. And so here for our Bristol sheet, we have these pieces all on the cut layer and all joined and closed. We'll cut and score layer. So I'll move this over to my Bristol cut sheet. Right now I'm not going to nest them. I'm just going to let them be. This would also be a Bristol operation. And in the grand scheme of laser cutting materials, Bristol is one of the cheaper materials to cut. It's very thin. It cuts very cleanly. So if you wanted to do sort of material studies like this, you could take, sort of two different paths to both approaches and try cutting each of them out, right? So you could look at what this one yields, what this one yields. If you wanted to get a sort of lattice on here, this could be a great case for isocurves. And so if I do show isocurves, I crank that up. Let's see. Yes, right. And so this could be a pattern that is scored into the material. I would say, now I'm not saying go into the DFL and mess with their settings, but sometimes you need to mess with the settings to get the exact result. If you score this as a sort of blue score, so let me just split these two apart. If you score this with like the default score setting for Bristol, it is going to cut too much, and this is going to be all sort of faceted. But you could lighten it, and you could even put it onto a black layer, which is sort of like a raster etch, really light. You could get just sort of the line work etched into it without impacting the structural integrity of the paper. So we'll put that up there as well. I put this in the wrong place. Move this over. And so I'll have like my sort of fragment one, and I can test this with tape and see how it comes together. Can I have my contiguous piece and test that as well. All right. And so I think for Bristol, we might come back to that for the orange skin again. But we'll move on to cardboard for a moment. And so I'm going to take a pause on the recording and build a site model really quickly. Okay, so I took a moment to go into this file, which should look familiar to some of you guys. This is a document I put together combining the existing site model with this building model. So we have the site line work, the curbs, the buildings, we have the streets, and then importing the 3D geometry of this building. I use that and our skill trick to arrive here. And so this will be the site extent. I will discuss the dimensions of this with the group, so I'm not going to put any specifics in the video. But trimming out the line work, we're looking to capture this adjacent structure, a portion of the street, and our building, and adjacent lot, or parking lot. These dimensions will be provided. And so we're going to take this, and I've pasted it right here. Now the one thing you might notice, if you look at my coordinates, is I'm way out in space. And so I really recommend this entire process. Really take your project, take anything you're working with, if you're importing it or just working on it, click on it and move it to 0, 0. So when you do the move command, you can type coordinates. So I'm typing 0, 0. You can set that up here, right there. And so that'll send me, I'm going to show you, send me all the way over here. And so, if you're out here in space like I am, when I imported things from the other model, you get lost. I moved it, and now without deselecting it, I can press ZS to zoom onto my selection, and I'm back. We're back in this area. And so all I'm going to do, I'll do two things. Before I put these together, I'm going to do cell polysurf. I'm going to deselect everything that I already have over here. And I sort of just want to filter out the line work primarily. Pesky clipping plane. Okay, let's see if we can find it. There it is. Okay. And so cell polysurf to get the 3D elements, deselect all of that. And so I already have a 3D model. I really just want to register these two things together, so I'm going to delete those. I'll keep this guy though. And so I'm going to use this outline, and I'm going to justify it with the southeast corner of my digital model right here. I'm going to be careful not to, let me think. So I already have, you'll see I'm at 0, 0 here. And so I'm okay if it moves in 3 dimensions because I want to sort of justify these two. So I'm going to come here, and you'll probably thinking that's not the building. So I'm going to pull it up to here. And it might help me to turn off some of my geometry so I can find this face. If you guys have more snaps on than I do, that's probably a little bit easier, but I'm stubborn. So we're going to pull the snap there, and then find that endpoint one more time, pull the snap right there. And we'll just check our work. So it looks like there's some slight deviation between the two models. Let's look at it in plan, see how bad it is. I'm not too concerned with this. If I do this view, nope, that's not it. This one, we can see it a little bit more clearly. So I'm going to group these lines so I can keep them all together. And so you'll see that this is a little bit off. I think that discrepancy is acceptable. And so what we'll do here is really simple. We'll keep the 2D line work of the site, and we will remove the 2D line work of the building. Because we have that, we have a model. And so just to bring it back to the point of this is a representation. We have two conflicting sets of data. We'll use the one that we've invested more time into. All right. And so as I mentioned before, I will be using cardboard for my base layer. And so I'm going to go on my cardboard layer. I'm going to hide the other pieces of it that I don't need quite yet, of the model layers. And I'm going to start creating some surfaces, some geometry here. And so I did explode this line work, which was not the right choice, but we're going to just rejoin everything. So the first piece of cardboard I'm going to establish is this block that our building sits on. And so I have all these curves joined, and I'll type close to create a closed shape. And then I'm going to extrude it. And so because we are working at model scale, we're going to be using actual measurements of the materials. I'm going to do 3/16 of an inch. That does not look right. Oh, that's because it's 3/6. All right, 3/16 of an inch. There we go. And so we'll start with this. And what we can actually do is, since we have this floor plate from my model I already made, and I know for a fact that the columns sit within that, I'm actually going to do something pretty simple, which is extrude this upwards. And I did not have solid off, so I'll type cap, and then I'll do Boolean difference, and I'll subtract this. Right, easy. And one more thing we'll want to do while we're here is we need to somehow join these two pieces together. So we're going to take this and we'll extrude it down. And then we will give each of these thickness. And so what I can do is if I do extrude surface, okay. Let's try that again. I'm going to do extrude curve. I'm going to turn solid off for this. And then I'm just going to extrude each of these out. And so what happens is I want this solid now. And I'm going to do 3/16 of an inch. I don't need to type an inch because I'm in inches. And then I can just, actually, I don't have to type that anymore. I can just press spacebar and it'll automatically extrude it to the same distance. And so we're going to look at the vertices here in a moment, but we still have some model information to capture. One more aspect. One more aspect of this site that we should consider during this point is the slope. And so what I'm going to do here is just use my cursor. I have this in feet. You can change the units up here. I'm just going to look at the sidewalk elevation on the south side of the building, 71 feet, and on the north side of the building, 73 feet. So it's about a 3-foot grade change on that side of the site, and about a 5-foot grade change on the west side of the site. And so I bring this up because some of you are working with that site grade change, and some of you are sort of neglecting it. If we need to accommodate it at this point in the project, we can do so by offsetting one edge of the sort of flat plate that we have here. I'll say as a classified requirement, I'm not going to do that right now, and so it'll be an optional addition to your site models. The other opportunity is to build up the contours from the background model, from the background line work, as layers and add them up. I will show that off, but I don't think we need to get into sloping the cardboard. And so looking at what we have so far, we need to do this sort of street piece here, and we need to do this sort of block right here, and then the building adjacent to our site. And so to do this, I'm actually going to come at it from a different direction. Let's come into the wireframe view. We'll do clean wireframe. And I'm going to turn off cardboard, work on this default layer. So to make this really simple, let's just select everything and do a hatch. Self-intersecting curves are found, and also I don't need this on yet. We can hide that for the time being. All right. So it looks like these self-intersecting hatches or lines are being an issue, so we're just going to do a make 2D here. And all we want to do is register with previous. Uh, Interesting. Okay, so we'll pull that over. I'm going to group this. I'm going to lock this. I'm just going to place this right into the same spot. And so now I can ungroup, I can explode, and then I can come in here with the hatch command, and I can do 2 rounds. I'm going to do this first round where I get this shape. I will want this as a solid hatch, and then I can do it again right here. to get this shape. And so the alternative is I could go select those curves individually, right? That's also perfectly fine. But with this, it's a little bit quicker, fewer command inputs. We did miss a portion, and so we can just come back here and do the exact same thing. So get the street and grab that corner that I missed, like that, and it will join them into one hatch, which is really great. I do have select boundary on, so I can take these hatches, I can explode them into two objects, like that, and now I can extrude these onto my cardboard layer. I'm going to extrude them down, and you see I still have my 3/16 of an inch distance in there. And so I'll delete the surfaces that I used to make these, and so now we're getting pretty close. One thing I'm going to want to do is just move this down by 1/16. And so now we get some definition of the curbs. All right. And so the very last portion is the sort of platform that this sits on, I guess second to last portion. And so I will do the same thing where I'll just pull these edges down for the time being. And so I'm just going to pull them down to the depth of our basement, to the bottom of our basement. And then I'm going to start to move these edges. And so you'll see something happening here, which is because some things are lower than others, they don't quite align. That's okay. We are going to fix that in a moment. And then we can copy this one over. I didn't extrude this edge because there's like four different edges. I could just copy the other one from the other side. And so what we get now is a little bit of air between our two pieces of cardboard. And then we also have to start to reconcile the thickness of the material. And so this is a twofold conversation of assembly and presentation. And so one thing to consider, I'm going to do something really quick. Okay. So here I put together a mock-up of the cardboard. And you'll see, so this is sort of what we look at when we have 3/16 inch cardboard. We have that material thickness. We have two veneers on either side, and then we have the corrugation in the middle. And so a decision to make is how do we join these, right? And so there's options in terms of which edge gets exposed. If we look at the side, the outside perimeter, we could pull, if we want this to be a clean face, we could pull this up, right? And we could sort of cover the side joint, but now we're revealing it on the top here. So that can make it more visible in ways. Another option is to get really high craft quality, is to use a knife or, some sort of like, I can't think of the word. They have this for foam core, some sort of like partial depth cutter to cut only the corrugation and backing and leave the veneer so you can get a really clean joint like this. This is pretty intense quality. And so I think instead we'll be clever with how we terminate these corners. And if you want to go the extra mile without, cutting each of these edges by hand or purchasing another piece of studio equipment, you can create an outline here like this. And you could cut that out of Bristol or out of craft paper, something that matches, and you could create a veneer and you could paste that to the outside to conceal those edges. And so what I'm doing right now is I'm going through and I'm cleaning up all these collisions. And so on the inside here, you'll see I've already done it. And I've laid out these joints. And this one doesn't really match the others, so I guess out of a high level of craft, I'll fix that. Set a good example. And so for my approach, I am pulling the walls down, and they'll go around the outside of this base piece. You could instead, and I'm just going to drag this and show you, you could instead pull this to the outside and have the wall sit on top of that yellow edge right there. It's really about buildability, tectonics, and to an extent preference on what you would rather build. It does, I think, take a bit of experience to know what you prefer, so I'm not going to prescribe to each of you. But I do think in some locations, like here, it's a clear choice. We want these edges to be concealed by our model and not be visible, not be on display. If we were to, have the vertical wall be exposed on its edge. And so I've been going around the outside and I've been taking care of that. And so you'll see I pull these edges down. In some locations, I have overlapping material. So that'll be solved the same way. I will pull this back like that. Right? And I'm going to try to match this on both sides. And so on this side, I'll pull the same face inwards like that. And then we'll do the same on this face as well. All right, and so now we have to solve this material conflict right here. So what I'm going to do is, this side is almost entirely the same height. I'm going to pull it to the highest height, and then I'm going to select the piece, and I'm going to use Boolean difference right there to get that notch cut out. Now this could be another conversation about what edge do you have visible, would you veneer that? I will not get into the minutia more than I already have. Here I'll do the same thing. I will pull this up and I'll Boolean difference out the street. And then coming around, I think those are the only two locations that needs to happen. So what we're looking for here, I'm going to turn off the default curves. Okay, this is a make 2D. Turn off the make 2D. I'm looking for clean edges. I'm looking for, no overlap of material. Because if I laser cut that, I'll have to hand cut it or recut it again to get these pieces to come together cleanly. And because we're doing digital fabrication, we want to benefit from the ease of construction. And so one more thing that we can do here to make this a bit more rigid of a structure, I think an easy one, a pretty obvious one, is to come in here with a piece like this or a series of pieces. Whoops. And create some sort of base to help the structure of the base model. And then we could do the same thing where we Boolean difference out these walls here. Now, again, this is us getting into a lot of cardboard land. And so we could also just make it a little bit simpler and say for this location, we could copy this piece over and use this as a sort of like rib that supports the project and gives it a bit more structure. And I say we could even do the same thing right here. And so this kind of thinking ahead will make the assembly much smoother. Now, as we make these larger pieces, we'll be challenged by I guess, one, the material costs, but two, the laser cutter bed. And so this model does have a dimension, I believe, that exceeds the laser cut bed. Maybe not. It does actually, yeah. And so most of our pieces are within laser cut bed size, but this street piece will not be. And so we'll have to be clever with how we maybe cut it and hide the seams. And so I'm going to take this last one, I'm going to Boolean difference out the street there. And so I can use these pieces to kind of help the rigidity of my overall site model. The last part here is the building on our site. And so I'm going to just grab these pieces. We're going to do the exact same thing. And so you'll see that my building's kind of falling off. I'm perfectly fine with that. I do think this is showing a decent amount of the building so that we understand what it is great. And so first thing we'll do is we'll offset the top down like this. And then we'll do the same for all the faces. We're going to pull them to the inside. So the outside footprint of the building remains the same. We have this kind of awkward face here. You see that it's not quite planar, but that's okay. And then we can turn off our default layer. And we'll do the same thing. So we're going to pull, I think in this case, I will pull these edges. If you're doing this on a chipboard, this really is not an issue. It'll be 1/8 inch, it'll be a little thinner. But you won't have to worry about the edges. Because I'm doing this out of cardboard, I need to make a plan about which edges are visible. I think this time around, I'm going to do the same treatment and keep the top face clean and pull these to the underside of it. And so I will see this sort of edge line here. Now, one easy solution that I haven't really acknowledged is this. So if I take this piece, I could put a hat on it made out of chipboard. And that doesn't have any ugly edge. And if you get, the same color, it won't really draw attention to it. All right. And so I have to do the same thing now on the walls. So I'm going to pull the, I'll say north and south edges in consistently. Like that. And so what that'll let me do on this piece is actually give it some more strength by making it larger. And then we'll pull this side in. Like that. And so always make sure you're doing that sort of consistently so that it doesn't feel haphazard. So now we have our site context model. Put some extra supports on the bottom to make it a little bit more buildable. And so now what I'll do, potentially in a speed mode, is nest this to my Lasercut sheets. And so this part's pretty important because it's going to tell you what your kind of material needs are. All right, and so the first thing I'm going to do is I'm going to copy it over to my cut sheets. I'm going to turn on, for some reason I have that on the map board layer, we're going to turn it on here. And so now we have to lay it all flat and take it apart. I'm going to do it with the 3D elements, and then we're going to sort of turn it all into Linework in one command. So I'm just going to take everything that's already flat to the ground and pull those out. You can also label your pieces if that's desired to make the assembly easier. Also say it's good to try to overlap edges where possible to reduce the number of individual cuts on your project. And then also to come back to this conversation, think about the directionality of the cardboard that is exposed and try to plan it so that it's consistent. And so I'm going to keep everything running. Here's my piece of cardboard. Depending on where you get it and how you're cutting it down, the grain of the material could run vertically or could run horizontally. And so you can be really deliberate with how you orient pieces on the cut sheet. I'm going to keep everything oriented sort of north like this. And so when I'm rotating pieces, I'm going to just make sure that they're all running that way. Now that will create in these pieces a little bit of, sort of looking at it in this axis, on the blue axis, it'll create some instability on that face, but it'll make it pretty strong compressively. And I'm pretty happy with that. And so with these outside walls, I can essentially take them all and I can either stack them up like this, or I can create a long line of them. Like that. All right, so I have everything laid flat here. I'm just going to piece it all together. And this is a personal preference on the next couple steps, but we really just need to arrive at the same place, which is flat. Laid flat, simplified outlines of all of this. The first thing I'm going to do is just come over to my wireframe view. I'll put it on the white background again. And just make sure that there's no bad overlaps. You see I have some complex cuts right there from where I contoured out the street out of that sort of rib piece. I also have this. This is a pretty large piece. Is this going to fit? So I have this bed here so I can kind of check my work. That'll fit easily. This is going to be also easy. Okay, I was overly concerned. So this will all fit. if we're really careful, we can get it all into one cut sheet as well. The one thing I'm going to point out is I no longer need this piece because I actually am using this piece as that now. And so there's two ways to go about this next part. You could do a make 2D of all of this. I typically I don't do it that way. I don't know why, but I prefer to explode everything, and then I'm going to take the flat 2D faces, and I'm on shaded, so I can just see that face. You know, ghosted, I might be grabbing the wrong thing. I'm just going to pull this out like that. And so if I check my work, I should have every piece. Yep, every piece is there. And so I have these a little bit more like laser cut line work. And so this is the step that takes it from 3D to 2D line work. And then the last thing I have to do then, I'm going to set my layer to cut. I can do extract wireframe, and I can pull this out. Now, if you guys are apt, you might be thinking, oh, you have overlapping lines. You're right. I'm going to take care of that in a separate step. But I do think I can successfully join these, I hope. See what my open curves are. All right. So I had a bit of a weird join, but it's pieces that I'm probably going to nest together anyways, so I will keep it okay. If you don't, I think the solution there is not to nest it in that first step that I was doing. Right, I already sort of nested things here. I could really just lay them flat and do that step. I'm going to delete this now. And so if we look at this, we have everything set up for cutting. We can come in here and do some scoring. And so I think some things to score. You also might do this at an earlier step. You could score the sort of sidewalk line or the property line, I guess in this case. You could even take the building outline that we have like this, and you could score that into the base of the model. And so if I need to check my work, because I didn't do that sooner, I can just come over here and I can check what that distance is right there, 4 inches. And I'm just going to take this actually, and I'm just going to move it to the exact same location on my model right there. And so I can take this and I can register it like that. And so I get a nice definition of where my property line is, and I get to see where the adjacent building is, which is going to make my life a little bit easier. I can come in here, I can explode it, and I can get rid of this line because it coincides with the cut line. All right. And there's other things that you could do. I mean, you could get really creative and you could write like the names of the streets in them. You could do crosswalks, you know. If you do something that's a bit more of like a hatch, which we'll be getting to shortly, you could fill these in, and you want to put that onto a black layer for rasterized etching, not on the blue layer. I mean, you probably can, but it's just going to be like a little overkill. So I'm going to take this on my cardboard sheet. I'm going to try to nest it and see if I can get it perfect. Now I'm saving the make 2D step for the very end, because if I have overlapping lines like this, especially in a material like cardboard, I want to get them after I've sort of flattened everything down and I've got it all situated. And so I can take all my pieces and lay them out. And you'll see here I'm getting some issues from the length of it, but I think I have enough margin on the side here. So one thing to keep in mind is cardboard gets pretty beat up around the edges. You may not want to put sensitive or important parts of your project right up on the edge of the cardboard because it might get a little bit chewed up. But I'm just going to sort of loosely nest this like so. Just make sure everything's contained. If I'm really concerned about efficiency, I can start to, you know, get everything even tighter together. Now, one other potential efficiency is this. I don't need to put this piece in here because I'll get it from cutting out the opening in that base plate. So I can just delete that because I'll get this piece right here, right, when that gets cut out. And then we pull in this. I actually don't even, oh, I guess it's this curb. We can overlap these two potentially. And so let me do one sort of final quality check. Now I'm being mindful not to rotate anything here because then I'll mess up all of that nice coursing I did on the cardboard direction. And so I think what I'll do is I'll just slam these edges together, and I'll slam these edges together like that. And just for the sake of, okay, actually, I'm going to pause. something that you will notice on materials like Bristol, Mapboard, Cardboard is when you get these perpendicular lines, you can sometimes see a sort of like burn hole where the laser slows down to change directions, or it might even do nonsense like cut this line, come over here, cut this line, and then come back here and cut this line. You'll see that. You'll see like a little sort of notch in there. And so you might want to avoid those, is what I'm saying. So I could avoid, in certain areas, I could avoid like pulling this up right there. Now it affects some materials more than others. And because I'm not actually laser cutting this, I'm happy with this nesting. And so I get my entire context or base model and building context in one cut bed, not even a sheet, a cut bed of cardboard. That's really great efficiency. And so we talked about Bristol for sort of curvature, talked about the site model. We'll be moving on to I think what a lot of people are going to be using, which is sort of a sort of 1/8 inch material, could be mapboard, and sort of doing these folded planes. And so I have a feeling that the folded plane conversation kind of makes sense from what we did over here with the Bristol, but I will do it again. And so let's look at this piece. Now I made this for fun. I mean, I don't know, I was having a good time, but also to represent some of the complex forms you guys have, complex moments, sliding planes, all of that goodness. And so I'm going to do this in I think two halves. And I'll say that you should each consider the viability of maybe simplifying or breaking things down into smaller components to make them easier to build, easier to fabricate. That's okay here. You can be clever with where those sort of seams get broken. Now I'm actually being kind of dumb here. You guys see what I'm doing? I could just select all my objects because it's a good layer I have set up here, right? And then I can copy this out. So I always like to copy because I want to know where things go when I have to rebuild it later. And so here I'm going to isolate it for a moment. I'm going to do cell curve. I'm going to delete those curves out. I don't need them on this version. And then I'll come out of the isolate. And so I think where I'll strike my sort of datum for the two different approaches is right here. So I'm going to explode this, and then I'm going to rejoin it. And I'm going to put this piece on this side. And so on one side of this, I'll treat it like an 1/8 inch material. On the other side, I'll treat it like Bristol. And so to kind of get me there, I'm just going to pull these apart. And then I'm going to set them to their, oops, well, that's the right way. Anyways, set one to Bristol, set one to Mapboard. And so the Mapboard one is going to be kind of the harder of the two. So I'll do the simpler form in Mapboard, but the technique kind of stands the same. And so for Mapboard, we're going to do the exact same thing we just did here with the cardboard. We're going to come in, we're going to add thickness to everything. I like to do this one by one. There could be a faster way, but follow your hearts. If you do a lot of them at once, it can be hard to set the direction constraint to a consistent thing, especially if not everything is parallel. So that's why I'm doing this individually. Now on this, we could definitely have saved some time, but that's okay. I wanted to be methodical. So I'm going to explode this, and then I'm going to start extruding. And again, I'm going to take my 1/8 inch, I'm going to pull these to the inside so that I keep my outer face secure. Okay, so I've sort of given this all some material thickness. And so here's an interesting conversation where if I want this to read like a sort of folded plane, I might actually use two materials here, especially if it's like a similar material like chipboard and mapboard and Bristol, or museum board and Bristol. I could let this be, the shell is one material, and then this sort of like thin edge, it could be even these pieces too, that could be a Bristol insert, which I think would not only look better, it would be easier to make. So it's a win-win. And so I'm going to actually exclude some portions of this for not just, I think, a craft conversation, but a overall design quality. And so I'm happy with this as Bristol. And we'll put that over with the Bristol pieces. And so I'm going to lock. I'm going to do, yeah, we'll do one layer on. I'm going to lock this stuff back here. Actually, that's the command. I'm going to do an isolate lock on this. I was like, I think there's a way to lock everything. Okay. And so what I'm going to do now is, because I did that, is I'm going to do cell open surf. Look at that. It grabs all those little surfaces that I turned into extrusions. I don't need them. I mean, I have them over here, but I'm going to delete them for right now. Now, you guys might already be at this stage. You might have thickness on your materials from your design project. I still recommend you each simplify it, and you prepare it for material thickness, and you sort of convert it in this process. So now what I'm going to do is I'm going to set this up for Lasercut. This is a folded plane, and I'm going to try to use some folding techniques on it. And one example is right here where I have this overlapping vertex. I'm going to take it, and I'm going to sort of set it to this like that. And so when I flatten these can all kind of like unroll in a really elegant way. And you could do something very similar with the unroll command, which I'm not going to discredit. It'd probably work fine if you had that surface that we just deleted that's all joined. Probably works just as well, but you will still have to negotiate these conditions here. And so in this case, I think I will let the outer face be continuous, and I'll trim that interface like that. Here, I'm going to pull this face up like that. And you know what? We don't have to do that. We do the exact same thing. That'd be very clean. Right? And then what I got to do here is I'm going to grab all of these pieces. I'm going to get them to an ortho rotation. It'll make my life a little bit easier. And then I can take this piece right there. Right? You guys see the vision? All right. And so I'm going to let this be a different piece because it's hidden, but I could even try to have that as a fold as well. So now that I got things kind of on an axis that is sane, this one is still just a little off. There we go. I'll do one last quality check on that to make sure everything's ortho. So this piece I will be treating as folded. All right, and so this is one of the pieces I said I was going to be doing out of Bristol, so I can actually just take them out right here. I don't need them in this pass. And so there's a really great reason to do this in this way. If you can unfold things, I will say this is like, this, it makes it more complicated. I'm not going to lie, but it creates other opportunities in the expression of your materials. Those benefits will be revealed momentarily. All right, we're almost there. And so this is, I mean, honestly, it would be the same for here. You could treat those all like planes and build it physically like that, but it'd be kind of maddening. I'm going to wager. I have something here. I'm just going to Boolean union these so I don't get that seam in the middle. And so a few of you brighter, or that's mean, a few of you really attentive students see what I've done wrong here, right? And so if we unlock selected, and we take this, I have inward and outward folds, right? So this is going to be a little tricky, but what I'm going to do really quickly is I'm just going to come and map the folds that do not comply. And so this is the right way. So I'm looking at it from the outside. I'm going to cut this from the outside for two reasons. One is so I have the folds on this face, and most of them are going to be on the outside, but two, I can actually laser engrave a material onto this. And so outside, And then we come here. This is an outside. And then this one's an inside. So I'm just going to make a little note for myself right here. And so this could be a great opportunity to just discontinue the two materials and make that a different piece where we have an inside curve, which is actually, I'm one panel over. It's this one. But I think to that point, I could discontinue it and then I could cut it backwards so that the seams are on the inside, right? We can be really creative here. It would actually be kind of nice because then we have the window continuous. But I don't feel overly concerned. I'm going to try to make it as continuous as possible. So we have an inside curve, which will be this joint. We have an outside curve right here. Inside, outside, inside curve. And we'll pull this piece apart as well. So this piece will sort of be like that extension. And then we have outside curve, outside curve, outside curve, right? Nice and easy. Now you're probably thinking, Sharad, you're not accommodating for material thickness because we're folding it. There actually won't be like an overlap in material. It'll come together pretty nicely. But that's why we have to account for the inside curves and pull them apart. Okay, and so if I really wanted to, again, I could mirror some of those, but I'm happy to keep it sort of like this. And so we essentially have an elevation of our entire building's facade. The other thing to look at is how are we supporting it, right? And so you'll see here, I sort of took a floor plate and I actually used the curve I made to extrude this outline. I took that curve and I just extruded it into a floor plate. So I could use this exact outline and I could glue my mat board to it. Material thickness would become an issue. And so the solution for this one, if we're taking this all the way, is I would do an extract wireframe. I'm going to deselect the top and delete everything else. I'm sorry, that was explode. Here, I'm going to run that back. Take it, explode it, deselect the top face, delete the rest, take that remaining surface, extract wireframe, join the wireframe, delete the surface, offset this curve inwards 1/8 of an inch. And so now that material thickness is being accounted for in the floor plate. And so if we look here, you see how they coincide. Now that with the thickness we added to this, we have the sort of clearance to keep everything aligned. And this will be perfectly aligned to this building face that we have here. So I'm going to take this, I'm actually going to group it. For really advanced models, I like to use model blocks for this because you can create a block of each component in the 3D model as it's assembled. You can map the 3D the curves to it as a 2D element, and because they're blocks, they'll update each other. But I'm not going to put that on you guys at this level. It's a bit involved. Now, Mapboard does not have material direction, so it doesn't really matter if I rotate this at all. I'm going to look at how that gets laid out in a little bit. So we have this, and so we're going to turn this now into a cut file. And I want to talk about some opportunities we have here. So I'm going to take the sort of flat face. I'm going to copy it because a lot of work went into setting that up. I might want to look back at it later, right? I'm going to save my time there. I'm rotating it in a way where I keep it sort of oriented in a way that makes sense. I'm going to look at it from my plan view, and I want up to be up, you know? I'm going to do the exact same thing where I just explode this into curves or into surfaces, and then I grab that outer face, right? And so now we'll do the nice extract wireframe, and we get this. So we will be doing a make 2D at some point on this piece, but for right now, let's think about it, right? We have this. This is essentially like our facade, and so we can take this as an opportunity to go even further with the materials and use the hatches in Rhino to add another level of detail. And so if I'm treating this like metal, I could put panel joints in it. And so one thing I'm going to do first before I go too far is I'm going to do a make 2D. Actually, I'm going to do it on this portion for the sole purpose of it's about to get really kind of complicated. Of course, I have make 2D turned off. I can do cell last to find my missing make 2D that's hiding in space. All right, so we have this. Do like the good old ungroup spam. We're going to explode it as well. And then I'm going to take it off of this make 2D layer. I'm going to set the print color and this ability to by layer, like that. All right, and so now we're going to set up the score lines, which are going to be these. Wherever we are folding, we're going to have a score line. In this case, we have fewer score lines than we do cut lines, so it makes sense to sort of treat it subtractively. Do the selection process on the part that has fewer components, make your life easier. So there's our score lines, and we could even group these if we wanted to. The cut lines here, this is where we're going to have things folding, so we need to preserve those cut lines. And so the last thing I'm going to do is if I select all of this, I can do the hatch command. And on the score layer, or even on, let me do a raster on the raster layer. Now I will say rastering does get kind of expensive because it goes really slow. Just put that out there. I'm also going to do an isolate lock on this. And then I'm going to select objects. And I'm just going to join these where I can. Because now the laser cutter will treat that hopefully like a continuous line and cut it really cleanly. All right, on to the good stuff. We'll use raster for this just so it's distinct in color. I'm going to actually put these together. And I could, remake 2D it to flatten everything. And so to do hatches, I'll select everything. I'll do a hatch. I can actually even turn off the score line for this portion too. And so I'll click my regions. By doing them together like this with the score lines off, it's a little bit easier. And so now I open the hatch window. And so really easily I could do horizontal, like almost wood paneling. Pretty basically, I could rotate this 90 degrees and treat it like some sort of corrugated metal or even, vertical running wood. I even have imported a brick texture here. You'll see that this is to real world scale. And so the actual scale we need, I think, is 0.0104. I did that on a calculator. It's really easy. 0.125 inches divided by 12 inches. That's the model scale we're at. And so you guys can get really creative here. And you can actually like etch these materials in here. Now, like I said, this is all laser cut time, and that's the price of laser cut. So you might want to go into the settings, make it faster, make it a little bit lighter, and so you get the idea of the material impression on there without like spending a million years. If it's on the raster layer, it will likely go slower. So just keep that in mind. But this is a really great way to bring a lot of material richness into a relatively basic model. And so for this, I will treat it as a sort of slat. And so you see these hatches here are already sort of scaled, so I got to just bring that scale back up. I might even make it a little bit smaller, a tighter spacing. And so think about the graphic difference between a vector and a raster. The black layer in a laser cutter is going to behave like a raster. And so if I have horizontal lines, that's not really the end of the world. But if I have, say, vertical lines, it's going to print it like a raster. It's going to go left and right, like a, ink printer, and just go beep, 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 back and forth. It takes a lot of time. And so you guys might actually benefit from putting these onto the score layer, which I have turned off right now, like that. And then you might even benefit, depending on how the printer will register the hatch, you might benefit from exploding these. Whoops, that's not it. From exploding these into curves like this. You could even get it crazy. You could do a green line, which the cutter has programmed into it, but you might need to kind of get the technician to do it for you. You could do a green line. And so this will still cut like a laser typically, but it will run vertically. It'll like treat it like a vector. The other opportunity is to just do two passes of score and turn the layer on and turn the layer off. So you could treat this could be blue as well. If the laser cut technician doesn't want to help you, you could treat this as blue. Do one pass like this with your sort of folding scores, and then do a second pass that's like this with really, really light etching. And so laser cutting is a product of speed and power. You could reduce the power and increase the speed and get nice light engraving on here. Just write down your settings if you have to do it again for another material in the future. And so this is going to be my map board piece. So that's sort of this approach. I think that the technique is, I mean, it's even simpler for the paper side. And so I'm not gonna, this is already a long video, and I'm gonna edit it. I'll post like an uncut version, but I think the technique stands here. If you guys really want to see me do this portion, like email me and I'll do it. But I think you guys probably get the idea. So I'd rather shift our attention to the sort of screening elements, the slats or the sunshades, vertical, horizontal, however you're doing them. And so I have two kind of examples here. I've already put them on my Bristol layer. And so because we're working at 1/8 inch scale and these are likely going to be really small, I suggest treating them like paper blades. And so the trick, the complexity comes from then how do we attach that to the building? How do we attach that to our models? So there's a few options here, right? The first is, let's look at this one. I'm going to do an unlock on this and take these, I'm going to take these two pieces out. I'll take all these pieces out. We'll study it off in the void. All right. And so let's look at this, right? A lot of you guys probably don't have things that are this complex, but I think it's good to use something complex to illustrate this technique. And so when I'm setting up my floor in this location, I could use the floor as a device to host these, which could work pretty well. I could also create something that's like sort of inset in here. I could create something that kind of overlaps the two to bridge them together. So what I'll do here is I'll just take the floor, extract the wireframe, and I'm going to take this curve, copy it, undo that, lock this, paste the curve back in, so I have that to work with. I probably could have used this, but that's okay. So I have this. If I'm doing the entire floor, I could etch it into the sort of outline. I'm going to treat this like a bridging component. And so what I'm going to do is I'm going to create it. I'm going to offset it. My offset is 1/8 of an inch. So I'm going to create a 1/4 inch strip right here, like this. I'm going to extrude it. The material thickness, which I'd probably be using Mapboard for this. I can shoot it up for now. And so what I can do, I mean, this is a really easy way to do this, is just take that and take these and do intersect like that. So if I hide my Bristol layer, you'll see that I've engraved the depth of the Bristol into the Mapboard. And so from here, I mean, it's pretty simple. If I take this outline and I take these curves, I could do this all as a Make 2D. This is a good time for Make 2D, I'll admit it, because there's just so many things like I could do Make 2D and grab all of these. I think register to previous is working against me, but that's okay. So this could be my cut layer. And so I guess the general strategy that I want to demonstrate here is just a way to take some material and use it as an interfacing tool for another material. And so these would be cut, and they can be sort of a single line cut because the thickness of the Bristol is so fine that we don't really need the material thickness. If you were doing this out of a larger material, maybe it's chipboard, and it's an 1/8 inch or a 1/16 of an inch, you could come in here, say it's 1/16 of an inch. We could do a two-sided offset of 1/32 of an inch to add to 1/16 of an inch. Or if we're doing an 1/8 inch, we could do a double-sided 1/16 of an inch offset to add to 1/8 of an inch like that. And now this is where it could be kind of tedious, depending on your appetite for it. You could do the same thing I did here with the actual surface and give the surface thickness and then boolean that surface out of this and get the outline that way, right? This will work, you know, it's going to be more work to do it the way I'm doing it here. So let me show the other technique. So say we were making all of these 1/8 inch. Ideally, we set it up that way, so we're not doing what I'm about to do, but that's all right. So I'm going to do the extrude surface two-sided, 1/16 of an inch both sides to get an 1/8 inch. And because I set it up the thickness, I can just press spacebar on each one twice to run the command with the same material thickness. All right. And so here I'm just going to actually use this filter over here. I'm going to disable surfaces so I can just grab the solids, right? This thing is exploded right now, so actually I got to turn it back on so I can fix that. But I can disable curves to clean that up. One closed poly surface, right? We'll disable surfaces, grab all this. We'll do a Boolean difference, subtract from all of these guys, or subtract these guys from that. And so now I have the same outcome, right? And so this was much faster than the way I was about to draw it. So if you have material thickness, I do think modeling it and Booleaning it into the piece, because then I can take this piece and I can use this, right? I have the notches cut into it. Okay. And so say I have to do the same thing to sort of vertical assembly like this. Now, if we look at it in context, let's look at what we have to attach it to. We have the floor plates behind it, right? And right now it's sort of offset. And so I could create a sort of mini structure behind it. That's the same depth as the floor plate. I'm just going to draw this line like this. Going to extrude it. Oh, I turned off curves. Extrude it 1/8 of an inch. Right. And so I can decide if I want it to run the entire width of this sort of opening in my facade or just the width of the mullions. Probably cleaner to, run it a little bit longer. I'd say it's the cleanest way to do it is actually build this into the floor, right? Rather than adding more pieces, more glue, more things to potentially break, right? And then all I'm going to do is, think about the level of engagement I want on these, right? So these are 1/8 inch, maybe less. And maybe I want like 1/3 of it engaged, of the material thickness engaged. And so if this is right there, this is 1/4 of an inch. In Rhino, I could also set the distance, and then I could do 0.125 divided by 3. And then there I get an exact 1/3 of the material thickness. And so now, same deal, right? These are treating these as blades. So I'll grab them and I'll grab this and I'll just say intersect. I did split, but I need to intersect. And now I can have those curves selected. I can take it with the sort of filling piece, right? And I can come into my Make 2D. Let me fix my Make 2D setting so it stops sending it to space. I think if I turn that off, I think I'm okay. No. Oh, that's so strange. So because I'm working at 0, 0, I don't really mind if it just goes to origin. And so this will be, again, it'll be on the cut layer. And I just want to make sure that this is the correct color when the laser cutter sees it, when it prints effectively. And so there's one way to sort of attach these. If they all had thickness, and say I wanted to add thickness to them, I could do this a little bit easier because they're all parallel to each other. I could come in here, I could do all of them, set up both sides, and I'll do 1/32 this time. And so now I have that. I can delete or hide or, group those surfaces to get rid of them. And now I still have this piece here. In this case, I'll actually join this to the floor. And so think about this, like fewer pieces is going to expedite construction. It's going to simplify your model. So you can kind of, if you had to distribute the pain of model building, you can do it up front or you can do it on the back end. The back end typically means a lot of glue, messiness, recutting pieces. You get like that, like, what is it? Like the ash of like the burnt material all over your fingertips because your hands are covered in glue. Or you can spend a couple extra minutes on the Rhino side and set it up really cleanly so that you print it out and put it together like IKEA essentially. And so you'll see here, if I put it into this floor plate, I just eliminated like not just this intersection here, but then like all the glue I have to do and making sure it's perfectly aligned, and then like a sort of weakness of the physical model, right? So just keep that in mind, and we can have conversations individually about like ways to translate components of your model. Okay, we're gonna go into a few random trains of thoughts here throughout the model. And so looking back at this piece, one of the elements you guys can use to create some depth if you're using a thin material, if this is all Bristol, you can start to create what is read as a volume by returning and folding some of these materials in here. And so I think to actually really look at this, I'll translate this piece into a folded model. Now, I do want to recognize not everything needs to be folded. It definitely expedites assembly, but it does also really complicate the front end. So if you are feeling kind of intimidated by the folding, don't feel like you're required to incorporate that. But I do think this facade specifically is a good example. I'm kind of scope creeping myself right now. I want to do a decent portion of it, but not all of it. So I think I'll take the selection I have now. One nice trick is if you have something and you want to be able to register it, you could move it like a fixed distance. Like I can move it 100 inches. And so if I ever need to come back, I can move it exactly 100 inches in the other direction, and it's you know relatively located to the other parts of this portion of the facade. So I'll move it 100 inches over here and zoom into it. And so this probably should be a copy anyways. It doesn't matter. Um, let's kind of take this apart. Let's look at how we would laser cut this portion. And so the first thing I'm going to do, if you remember our study earlier, is like look at some of where we have the concave transitions. Those are not going to want to be contiguous folded planes. And so I think this is probably going to be one piece. And then we might somehow join it with this piece on the bottom here to the rest of it over here. So we'll pull this facade off. So we'll pull this side of the facade off and kind of study this. So we'll do the same thing, right? Treating this like it's folded, I'm going to try to get these two guys oriented onto an orthogonal axis. So I'll grab the rest of this side here. And flatten that out. And so the idea I have here is because this is a sort of internal angle and scoring is only working on sort of either, internal or external folds. If you're doing an internal fold, you do kind of need to mirror it for it to translate correctly. If it's simple enough, it doesn't really matter. This is kind of complex, so it would matter. I'm going to use this as the rotation axis. So this could stay one piece of paper. And so the way I would do that is actually kind of easy. Just do a rotate 3D. I'll set my axis to that fold that I want to create, and then I will set my rotation angle and do a 90-degree rotation. Now this looks pretty crazy. It's really complicated now because the remaining part of my folding area is 90 degrees to the work plane. So I can just take this whole thing and just rotate this like such. And so now the part I'm ironing out is all this stuff over here. And so the first thing we'll do is, you guys see the issue here? If I lay that flat, it's going to conflict here. So I think this will sort of rotate with everything else over here. And so when we're doing this, again, I'm fixated on rotations and folding because it does really help the model process outside of Rhino. But you guys don't have to do this. I'm just sharing this for the people who are interested in it. And so I'll rotate that to lay it flat to the work plane. So at any point, if I need to like simplify what I'm doing, I can always just kind of like rotate it. Here I get some bad intersection. Trying to debate on how much that bothers me, but we'll leave it for now. And so it might be a process where there's two bodies. I'm definitely overcomplicating this portion of the model, but this can kind of get pulled out as its own thing, like that. And then this part can get rotated. And so this is actually a really logical spot for a break because it goes to an inside angle. And I want to bring this with it. So the general takeaway from this is to find opportunities to simplify everything outside of Rhino because you have such a higher degree of accuracy in this software. There are things that you can do in here that take a second that are very easy and will make your life much, much simpler when you have to build it on your desk. Right? And so I could take this into maybe like 2 or 3 pieces, depending on where I want the seams to land. I could even take this as one piece, right? And so I can sort of figure it all out here before I even set up my outlines and my cut lines and all of that and decide how I want it to fold. And then again, just to look back at that process over here, once you have all that decided, you have the opportunity to come into the 2D projection of this, the flattened and unfolded portion, and keep designing that facade. And so right now I'm looking at it as a material process, but it could also be openings. It could be, a design tool. You could also look at things that might get layered behind the facade and build up multiple pieces of chipboard to get certain effects or to build, window trims and projections. One of the challenges each model will have to reconcile at some point is because we are using, let me turn this off. Because we are using dowels in this process, there will be an element of hand cut pieces, and we'll have to plan how they interact with our laser cut pieces. And ideally, we get to build this once and we build it right and it comes together really smoothly. And so I'm gonna take what I have here and copy it just so we can talk about this sort of sequencing. And so one trick that I think is gonna help probably everyone is these things are gonna have to be hand cut. And so you're gonna have something that's sort of less accurate with a very accurate piece. So you can actually use the laser component, like the laser production, to expedite what you guys have to do physically. And so what I mean by that is, for instance, we could take these beam locations and we could intersect them, maybe not the actual intersect command, but we could intersect them or do a make 2D, some way to translate them to the actual floor. And so if I do it this way, it'll probably give me a cleaner, simpler output like that, right? And so we already have the holes cut out, but now we can get the exact beam locations going this way. I'll group those, and then I can do them going this way. I'm doing it in 2 pairs, or in two passes, because I don't want to intersect the beams to each other. It just adds an extra step of cleaning all those lines up. But if we pull this apart now, I can essentially locate all of these in Rhino. And when I'm building this with my dowels, I'm just kind of lining them up. So let's actually look at that. The one thing you guys need to be careful of is not building this. Don't build what I have on the screen right here. At least not at first, because if you take this approach, you build all of your dowels and make this nice cage. It does look very cool. How do you actually put the floor plates on, right? If there's collision on this stuff, you're going to have the beam sort of stopping the interaction of the columns and your floor plate. And so the right order of operations is probably something like this, where the horizontals are like a second step to the verticals. You'll also see that I have a bit of a consistent technique on the continuous structure. And so I'm using my north-south beams. They're continuous. They run the entire length of the building, but then they die behind the verticals. The verticals, I think, get priority consistently here. Everything else is sort of secondary. And then these east-west are tertiary. They get broken up by the verticals and by these north-south horizontals. And so I have kind of like a few pieces that are sticking around here. Let's take these out too. So the reason why I'm pulling this apart is so I can show you, like if you are building this, you can set up these dowels on your desk. You can cut all these lengths. These will all be the same length too, which is kind of nice if you model it this way, because then you can just kind of cut a whole bunch of them, set them up. And so we have 3 floors. What you could do is you could take your ground floor. You could even take, let's back up a second. I'm missing a great opportunity here. Let's unlock this piece and let's copy it using the floor plate as a reference point. So I guess let's back up. You could engrave these into the floor plate like this. That could be an intersect, or you could actually cut it, right? You could even do 2 layers, if you have one for like the sort of base layer of your site model, you could cut them into this one and then make a sandwich. So there's good opportunities here. What I'm doing right here is really simple of just engraving their positions so I know where they sit. That's going to already make things a lot easier. And then I can take my ground floor like this. And so I'll have to use some sort of measurement or some sort of device to know where this sits, right? There's all sorts of different tools you guys can use. You could cut out a piece of cardboard or really anything and use it as a spacer. And so if we have 1/8" right here, we can make that like a piece of material, right? You can even extrude, nope, not that one. Extrude this. You could take this and cut that as a piece of cardboard, and then we have a little device that we can use just to check our floor heights and make sure it's even. You can make a few of these and use them as scaffolding while the glue dries. But just backing up, so we could set this height, and then we can come in with the ground floor beams. Looks like I moved these guys too far. One of these is in the wrong place. I'm not sure how it got there. I think it's these though. Right? And so we take the ground floor structure and we'll glue that into place. So imagine this is like, physical model on your desk. You can interface all of the interior columns, get all the exterior columns set up, and then you can kind of glue this to the bottom of that. Right? And we can use these lines that we have right here to line them up. Right? So that's level 1. We can come in here with level 2, do the exact same thing. So remember to put the floor on and then bring the columns in, or sorry, the beams. It's late, it's been a long day. Bring the beams in and glue these into place afterwards. Because once you bring that in, you're not going to be able to lower the floor on. I guess you could place all of these beams by hand and then drop the floor on top. There's nothing stopping you. But think about this. Which sequence of events lets you use some sort of, guide, right? Some sort of like device to make you more accurate. Like in this right here, let's do clean wireframe. In this approach, you have these guys that will tell you where to place the dowels on the bottom side of the floor. Whereas the other approach, placing all these dowels and then putting the floor on, you're kind of working blind on the dowels, right? And then you're going to hope that this lines up perfectly. It's kind of risky. So always be looking for, digital techniques, or as you're working on your model, you don't have to do it all at once. You can kind of work on it in stages. And so as you're building it, like look for things that you can improve in the second or third cuts that will smooth the assembly and help you work more accurately. And so the other thing to keep in mind is as we're building this, I don't have any stair towers cut, but let's say I cut one. We'll make it about that size. I'm not working at a real world scale, so I'm just kind of eyeballing my stair tower, but you guys all have them modeled. So you'll take your stair shaft, I'm going to cut it like this so I can do this. And so thinking about sequence, if I need to build walls in here for my stair tower, which would likely be out of a 16th inch, but it can also be an 1/8 inch material, if I have to put these walls in on the inside, I'll make them 1/16 inch. Does it make sense for me to do that right now when my model is, really open and I don't have a roof on it? Or should I put the roof on and then try to put my stair tower in? Like that's going to make things much more challenging. And even to that same thought, this base piece potentially should not be integrated into the site model. It could benefit you for the base piece to either be removable with the model or to have like 2 layers at the base so that you can pull this out. Because you're going to want to be able to work on this or even take it out, modify it, or show, at the final, show the jury your model, show them your hard work. So having the ability to take this out of the site model is really important. So part of this process of capturing materials in our scale models can leverage hatches as a tool to be engraved onto whatever material you're using. Now, the base hatches in Rhino are pretty lackluster. If I just grab this, um, I think I have a few imported hatches in here, but this is, I think, the default Rhino 8 hatch set. And so I was doing some research as I made this video where we can pull in a wider library, and I came across this page on the McNeil website. So this is wiki.mcneil.com/rhino/drafting page. Now this is an old article from 2024, it looks like. If you look here, there is a see more custom hatch patterns for Rhino 8. This is a bit more current. And so you can download this hatch file off of here. This is actually not the one I use. There's probably even more in here. And you'll see what some of these patterns are. So I would say probably both of these hatch files are useful. I'm going to take the English version here. I already downloaded this, so I'm going to have a whole bunch of those in my downloads folder. And so I guess what this second page is useful for is the importing process. And so there's 2 steps. On that first page, the hatch is set up as a TXT. And so you'll see I have the download here. I extracted this folder and uncompressed it. And so now I can open the TXT and you'll see the hatch values are in here. And so all we have to do is just do a save as right here, click on file type, do all files, and then add the .pat file extension like that. We look at the other one. Let me see this. This is Rhino here. This is already set up as a PAT, so you don't have to do anything here. I'm going to import this one and we can compare the two. And so the reason why I spotlight this page is because this is a more modern article, and so it shows the current user interface. The process here is sort of like in the files of Rhino 5 or Rhino 4. So these are no longer relevant, but for Rhino 7, Rhino 8, it'll look like this. So you can click on your settings icon. If you're on Mac, that lives up here in like files and settings, or sometimes it's called preferences. Click on the gear for Windows and you'll see the hatch page right here. And so you can import the hatches. So here's where I have the hatch patterns that I just set up. And so when I do this, you'll see I can actually view all the hatches that are in that file. There's quite a lot in this one. And so a lot of these are really ornamental, but you could use them and even abstract them to be a perforated screen, to be, sort of floor texturing, like paving, different tiles, There's clay roof tiles, which would be an interesting addition in this design project. And so there's a ton of different hatches in here that are useful for both vertical, wall surfaces or horizontal floor surfaces. You'll see some of the brick patterns I was using earlier here. And so you can select the ones, and you'll see if if I do Control A, I can deselect all of them and I can just pick the hatches I want. You can also bring all of them in. You will get a pop-up. Say I bring all these in, you might get this pop-up here saying the hatch already exists. You can probably proceed with yes to all. I think a lot of these are the default hatches that are already in your Rhino file. So I'm going to cancel this one, and I'm going to import the other one I just installed called Rhino, and we can compare. So this one is really not that robust at all. These are drafting hatches that are useful, but they're not going to be great for the laser cutting, like of bricks or of pavers or tiles. And so I would say this hatch file provided here on this link at the top, and you can download the English version. I'd say that is a really great addition to your Rhino files. And so once you bring these in, we are working at 1/8 inch scale, and some of the hatches in that initial file are scaled for, kind of, I guess, building scale. So you might need to scale them here. There's a couple ways to do it. So if I make my brick hatch like this, you'll see that the brick is very large, right? And so what I have to do if I actually want to see that brick hatch, is I actually have to, so you can see right there, I actually scaled it and it updated with the brick. So you can see that this is like about the size of a brick. I can change the scaling right here in the hatch properties. And so the way that I arrived at the hatch scaling, we are at 1/8 of an inch. And then if we divide that by 1 foot or 12 inches, we'll get this. And so you can essentially just paste that right in there for the scaling, and it'll give you what the brick is at our very small 1/8 inch model scale. Some of the hatches that are already in Rhino, like these vertical lines, are scaled a bit differently. These are sort of set up for page scale rather than like building scale. And so you might run into an issue where, like, if you put these at, that small scale, they're going to basically turn opaque because they're so small. So just keep an eye on the scaling of it. Some of the hatches are going to be fine at 1.0 scale. Other ones are going to want to come down to 1/8 inch scale so that they fit the size of your model. And even with these, if you want to, make these lines tighter, you can scale them themselves for tighter spacing or for, wider spacing as needed. While you're working in here, consider, working in 1/8 inch scale. 1/8 of an inch is about a foot, right? And then that would leave a 1/16 of an inch at about 6 inches. So I know these are not very visible. Let me switch layers. So here's what that looks like. So here's about a foot on this hatch, and here's about 6 inches on this hatch. And so you can use that as you're scaling these to kind of get a sense of, what the size of this material would be. And so if I bring this down to about 0.6, I think, it looks like I'm pretty close to that 6 inch spacing. It's still, even then, still a little large. I can bring this down to maybe 0.5. And so if I wanted something that is even tighter, this is like a 6 inch plank, for instance, I could do something even tighter like corrugation, corrugated metal, or some sort of slats that I'm abstracting. I could bring it down to like 0.25 or even lower, like 0.2.